A Brief History of Earth, 4 Billion Years in 8 Chapters by Andrew Knoll. He is a Fisher Professor of Natural History at Harvard University, receiving a PhD in geology from Harvard in 1977. He has made groundbreaking research on Earth and the environmental history of Earth, having received numerous awards in the geology field. His latest award, the 2024 Penrose Medal, a top prize awarded by the Geological Society of America, kind of equivalent to like the Hall of Fame recognition in sports. But this book covers 4 billion years of Earth history in 8 chapters, following like a chronological order. It seems to be a lot, but it's not. Unlike traditional science textbooks, which are designed for exams, problem solving, usually divides the knowledge into separate subjects such as biology, geology, and chemistry that are far more dense with information. But this book is not a science textbook, but a non-fiction science textbook that gives more of a biography of our planet in a unique way that is written to help readers understand Earth history as like a whole, in like storytelling type of way, which engages readers. If we look into chapter 1, The Chemical Earth, the Birth of the Universe. In this chapter, Andrew Knoll takes us to the very beginning, 13.8 billion years ago, when the universe emerged from an intense, hot, and dense singularity, the Big Bang. A violent expansion set the stage for everything that followed, releasing fundamental particles such as quarks, leptons, and gluons. As the universe cooled, these particles began to bond, forming protons, neutrons, and eventually the first hydrogen atoms. Knoll, a description of gravity as like the architect of the universe. He explains how gravity shaped the cosmos, pulling matter together to form stars, planets, and everything what we know today. This chapter is a vivid introduction to the chemical and the physical processes that helped Earth formation, setting the stage for the elements and the compounds that will eventually shape our planet. This book also offers a very clear explanation of how we got our first stars. To summarize, these hydrogen atoms clumped up together under gravity, forming a dense clouds that collapsed into protostars. Once the core reached into a high enough temperature, hydrogen fused into helium, triggering the birth of the first stars, known as population 3 stars, which were composed mostly entirely of like hydrogen and helium. This book also explains how stars eventually die out, with the massive stars ending in supernova, the spread of like heavy elements into the space. Smaller stars like our sun become red giant and eventually white dwarfs, contributing to the creation of new stars with heavier elements like carbon and oxygen. This process led to the formation of population 1 stars. Now, near the end of this chapter, Knoll then shifts his focuses on the most critical feature of life, water. One of the earliest hypotheses was that icy comets were the primary source, but he writes at the book that they were likely provided less than 10% of our water supply. Instead, he points out the combination of volcanic outgassing and, the most importantly, chondrite meteorites being the main source, eventually forming oceans. Now, in chapter 1, Chemical Earth, he introduces us to like the planet raw ingredients. But in chapter 2, the physical Earth, is where he shifts from the chemistry to the mechanical and the structure processes that built the ground that we stand on. The Earth's core intense internal heat drives plate tectonics, which I found fascinating is how Knoll describes the rise of continents. They didn't start large, they began as like teeny volcano islands rising from the sea. Over billions of years, these islands collided and merged, forming the first supercontinents. But this massive land masses would eventually break apart, only to drift and collide again, forming entirely new supercontinents. One of the supercontinents, Gondwana, a massive landmass that once unified South America, Africa, India, and Antarctica, and also Australia. He explains that the Earth's internal heat pushed away these plates. To example, between South America and Africa literally opened up the Atlantic Ocean. The Indian plate that was once connected broke away and moved northward, being in a head-on collision with Asia, creating what we now know as the Himalayan mountains. The term used is a convergent plate boundary. So at this point of the book, we don't see any sign of life, but that will change in chapter 3. Chapter 3, the biological Earth. This chapter explores the origin of life and the roles of RNA and DNA in the early biology. However, Andrew Knoll points out that scientists still don't know exactly how life began, with the RNA world hypothesis leading to the explanation of origin of life, possibly coming from hot hydrothermal vents. Some scientists also believe or are enthused about the panspermia hypothesis, the idea that life may have been seeded from aliens or comets or meteorites. Knoll emphasized that the origin of life remains as a work in progress. While we can't really yet fully explain how life started, we can estimate when it first appeared on our planet. Scientists look for rocks for answers. If life existed millions of years ago, then there are rocks where its traces would be preserved. The Spitsbergen Island, where researchers uncovered these rocks containing teeny fossils that open a window on Earth's earliest life. The finding of organisms dating back to 800 million years ago. One of the many organisms were cyanobacteria. This cyanobacteria, if you ask me, played one of the most crucial roles in Earth history. And we'll learn that why in chapter 4. In chapter 4, the oxygenated Earth, how did Earth get its oxygen? This is a chapter Andrew Knoll compellingly explains how oxygen transformed our planet through the close interaction between Earth's physical processes and life itself, cyanobacteria. Cyanobacteria performs oxygenated photosynthesis by using sunlight to split water molecules, releasing electrons, protons, and most importantly, oxygen. This process produces oxygen as a O2 as a byproduct. The emergence of cyanobacteria directly triggered the Great Oxidation Event, the GOE, dramatically increasing oxygen levels to the Earth's atmosphere. A quote from this book, it was the interaction between Earth and life that transformed our planet's surface. As oxygen accumulated in the atmosphere, it opened up the doors to entirely new forms of life, most notably the evolution of eukaryote cells. Each chapter of this book presents a distinct area in Earth history, building a logically on the one before it, strictly following chronological or structure that makes the narrative easy to follow and very well written. As you read, you will see the emergence of eukaryote cells laid the foundations of major evolutionary milestones, eventually leading us to the Cambrian explosion, life coming out of water, the early amphibians to the dominance of the dinosaurs to the fall from the meteorite hitting Yucatan, ultimately leading us to the rise of mammals. In chapter 8, the human Earth, the last chapter, in the beginning, he introduces the early hominids, most well-known Lucy from Ethiopia, to the Homo erectus, where Homo species stood upright, to the evolution of the Homo sapiens. But he then shifts the deep geological past to the present day, examining the profound impact of human activity on the planet. He frames that humanity as the new and unprecedented geological force that is altering Earth's system as a speed far greater than most natural processes. Knoll explains that unlike previous life forms, humans can rapidly alter Earth's system through agriculture, industry, and the fossil fuels, just to name a few. But the core concern is that accelerating global changes will lead to more frequent extreme weather events worldwide. With these shifting environments, the people are left with very few possibilities: adapt, migrate, or face extinction. Final thoughts. Now, this is actually one of my favorite geology books. Andrew Knoll presents the material in a way that it feels like a continuous story of the planet rather than a traditional textbook. It's an excellent source, a book for anyone who is looking to learn about the Earth that we live in. It's highly regarded by geologists and scientists alike and having received consistently strong reviews. Published in 2021, it's about a 250-page book. I also liked how he referenced other professors and researchers, naturally making their work part of the narrative. What stood out to me the most was the organization. This book condensed an enormous amount of information, geology, climate, Earth history, and the evolution of life into a clear, engaging narrative that is easy to follow. He blends scientific explanation with a historical perspective, showing how Earth has changed over billions of years without overwhelming the reader. In this description, I'll have a link to where to get the book, but let me know in the comments below if you have read this book, what you enjoyed about it, or if you plan on to read it. If you enjoy this review, hit that like button, and to help out the channel to see more content, hit the subscribe. Till next time.